Hello everyone, my name is Colin, and in this video I'll give you a tutorial on how to use the application EduLogicSim. In the description below I'll have the website so you can download the app. When you first open the app, you'll see the license agreement that you have to agree to. So click Read Agreement and this menu will pop up. Scroll down all the way and read it, and click Close, and then you can click the check mark and launch the simulator. When you first open the app, you'll see the main interface with the component library organized into clear sections at the top. The logic gate section contains your basic building blocks, including the AND gate, where the output is high only when both inputs are high, an OR gate, where the output is high when any input is high, a NOT gate, which inverts the input, a NAND gate, which is an AND followed by a NOT, a NOR gate, which is an OR followed by a NOT, an XOR gate, where the output is high when inputs are different, and the XNOR gate, where the output is high when the inputs are the same. Moving to sequential elements, we have the D flip-flop, which stores data on a clock edge, the JK flip-flop, which can set, reset, hold, or toggle based on its input, and the T flip-flop, which toggles its output when the T input is high. The input and output section provides components for data generation and monitoring, including the clock generator, which creates timing signals essential for sequential circuits, the 8-bit input component, which allows you to create programmable data sequences, and the 8-bit probe, which monitors 8-bit values and displays them both in binary and decimal formats. For signal sources, we have the switch, which provides user-controllable on and off signals, logic 0, which provides a constant low signal, and a logic 1, which provides a constant high signal. Finally, the annotation sections includes the text box feature for adding labels and documentation to your circuits. The file operations lets you manage your circuits with new to start fresh, save to save your work, save as to save with a new name, and load to open existing circuits. The education section provides access to digital logic lessons, which opens 6 comprehensive lessons covering everything from number systems to memory systems. It also has activities to apply what you learn. The simulation controls are crucial for circuit operation and include Start, which begins the simulation, Stop, which pauses the simulation while allowing you to continue from where you left off, Clear All, which removes everything from your workspace, Waveforms, which opens the waveform viewer for signal analysis, and Reset Data, which gives you options to clear simulation data either completely for a fresh start or just to reset the timing while preserving existing waveform data. The main canvas is where you build your circuits, and it includes zoom controls at the top to let you zoom in and out to see fine details or get an overall view of your design. Let me demonstrate the basic workflow by building a simple circuit with an AND gate. I'll click on the AND gate in the logic gates and add it to the canvas. Notice how it automatically snaps to the grid when I move it, which helps keep everything organized and aligned properly. Now I'll add 2 switches for inputs, and I'll just move them to the left and a little above and a little below the AND gate. To connect these components, I click on the output pin for the switch, and instead of just connecting it straight to the input for a diagonal line, I'll click on an intermediate dot to make nice 90-degree angles, and then click on the input for the AND gate. I'll do this for the same for the bottom one. And there we go. Now I can right-click the switch to toggle the switch on or off. When I run the simulation by clicking Start, we'll see the AND gate turns green, meaning it's on. I'll click Stop to stop the simulation. Additionally, if I click on the output pin for the switch, when I don't mean to, and I don't want to have any wires, so I can't put it anywhere, I'll just click the escape key, and the wire goes away. So that's how you delete a wire. Next, I'll show you how to use the input and outputs. So I'll click on clock generator, and this little menu will pop up for the hertz, and I'll do 5 hertz, so that means we'll have 5 clock signals in 1 second. I'll put an 8-bit input, and this 8-bit sequence editor menu will pop up, and it'll have 20 rows, and the default is all zeros, so I will use a binary counter to count from 0 to 19. Then I'll attach the 8-bit probe, and I'll connect all the bits together. Oh. Now I'll move this clock down and attach Q to clock. And so look at the waveforms. I'm going to right click on a component and click monitor waveforms. So I'll do that for all these three. And when each clock signal hits, we will go to the next row for the 8-bit input. So when the simulation starts, we'll start at row 0, then a clock signal comes in, and then we'll go to row 1, and so on. So now I'll click Start to run the simulation, and now I'll stop it. I'll click on Waveforms, and this menu will open up, but it's very hard to see everything. So at the top we have the zoom in, zoom out, home, and a pan left and pan right. So let me zoom in so we can see. And then I'm going to go all the way to the start, so pan left. So now we have the clock as the top, the 8-bit input, and the 8-bit probe. We can see that on each rising edge of the clock, the 8-bit input and probe go up a number. So it's like a binary counter basically. And we can go all the way to the end, and it'll start counting in hexadecimal and binary. This is a simple 3-bit counter I made, which are using T flip-flops for a divide by 2 circuit essentially. I'm going to click Start to run the simulation, but first we can see that I'm monitoring the waveforms for the clock, all 3 T flip-flops, and the 8-bit probe. Alright, now I'm going to click on the waveform viewer, and let's say I want this 8-bit probe to be at the top. So I'm just going to select on this and drag it all the way to the left. And now it will be on top, and the clock was moved to the bottom because they swapped. We can zoom in, and we'll see our count in decimal and binary. We can also have this red cursor line that tracks your mouse so you can see where all the clocks line up. If you don't want this red line, you can click at the top, Show Cursor Line, and there will be no more line. Additionally, when you close the waveform viewer and you want to continue from where you left off on the waveforms, you click Start and you just click Stop, and it'll leave off at the same point. However, if you don't want this, we can click Reset Data, and you can choose your options. We'll click Yes. So now I'll start this again, and now stop it. And as we can see, the data resetted for the waveform viewer.